Okay guys, so let's finish up your notes from last class. Okay, so we're looking at our notation now. So this notation that you'll see right here, whoa, that was the wrong button. This notation represents this limit, okay? Just like your derivative notation represents a derivative limit. It's the same sort of thing. So I'm just gonna zoom in so it's easier to write. Okay, so we're gonna start with our endpoints. So your A and your B represent your starting point of the interval. And B represents the ending point, or the end point of your interval. Okay? If you think about the definition, right, we said you're dealing with this interval A to B. That shows up in your notation on as the bounds of your integral, excuse me. So then, wow, this is so messy. Oh well, at least you're listening. Okay, so here we go. F of x is the function you're integrating. And dx is the variable you're integrating with respect to. Right? Just like when you took a derivative, you always had dx because you were deriving, or you had dy dx, right? You're taking the derivative of y with respect to x. In this case, you're taking the integral of your function with respect to x, okay? If you were dealing with like a time situation, this would say dt. Okay, now, the only other last piece of this notation you should know is that this f of x dx term is what we refer to as the integrand. Okay, so you'll hear that phrase, like what's your integrand? What are you integrating? The other thing that you want to keep in mind is this dx is extremely important. If you do not have it, you will lose points on every quiz and every test you take until the day you are done with all of your calculus classes, not just mine. Okay, it means something. You can't just ignore it. Like when you're taking a limit, you still need the limit symbol. When you're taking an integral, you still need your integral symbol. Okay, so we're going to start using this notation to represent an integral because eventually you're going to know all the rules for this notation. So it'll be easier than taking the limit each time. Just like with a derivative, at first you took the limit each time. But now you're not going to need to keep calculating the area in your partitions because you're going to create a set of rules for this. And it'll make your life a lot easier. So the first rule you are going to learn is the rule of what happens when you integrate a constant. So here we go. If f of x equals c, where c is constant, on the interval a to b, then, listen to the language I use because it matters, the integral from a to b of f of x dx, and then if I just took my function, I'm plugging it in, is equal to the integral of a to b of c dx is equal to c multiplied by the difference of your endpoints. Okay, so we are going to use this new rule that we have to re-investigate that ship problem I gave you guys last class. So, here we go. A ship sails at a steady rate of 7.5 knots from 7 a.m. to 9 a.m. Okay, so that's going to be my interval, right, obviously. And my function, in this case, is velocity with respect to time, because velocity is always with respect to time, is equal to 7.5. So if I use my new integral formula, or my integral notation, I would say the integral from 7 to 9 of my velocity, or my distance, sorry, is equal to my integral from 7 to 9 of my velocity of t. And I'm taking the integral with respect to t. Okay, you're taking the integral with respect to t. So if I plug in my function, I go from 7 to 9 of 7.5. Don't forget the dt. Okay, right? It should match this notation that we have here. And then that's going to equal 7.5 times 9 minus 2. 9 minus 7. Where's my eraser? 9 minus 7, which would then be 7.5 times 2, which is the 15 miles or nautical miles that we found in class last time. So on your homework tonight, part of the homework is asking you to figure out the integral from, I don't know, 2 to 5 of x squared dx, for example. And what that means is, and it says use the area. So what it wants you to do is draw your function, and you know what your function is, it's x squared, and you know that, because if, whoa, that was way too small. If you go back up to your notation, right, your function, your f of x is right there in your integral. So it wants you to draw x squared, so x squared is a parabola, but it should, that's a terrible parabola. There we go. And it wants you to go from 2 to 5. And then in class, I told you to use the number of partitions that was the same as the size of your interval. So in this case, your interval has a side length of 3, so we're going to use 3 partitions. And you can choose whether you want it to be a rectangle from the left, a rectangle from the right, or a trapezoid. Just be consistent. If you start with a trapezoid, they all need to be trapezoids. Okay, that's it. Let me know if you have questions.